Okay guys, so let's start. So the first tip is understand how to use the three rules correctly, right? So always know how to use these three rules correctly: the sine, the cosine, and the area rule. And you're also required, guys, to know how to solve the identities. So if you're still having struggles in solving identities, you can visit our video on solving identities. I'll provide the link here and you can check it out. And also you can check out how to solve equations. I did a video on grade 10 work that deals with solving equations. This is the link to it. You can go and watch it if you're still struggling with that. And then from then, after applying these rules correctly, guys, use algebra to solve for the unknown. So you must also be able to use your algebra right, guys, right? Always learn how to use your algebra right. And then after that, you must also be good in Euclidean geometry, right? You must also be good in Euclidean geometry because some of the statements that we are given in these questions, they require us to have knowledge on Euclidean geometry, right? Knowledge such as if you're having parallel lines, how you can apply, or if you're having equal lines in a triangle, you know how to apply that according to Euclidean geometry, right? So revisit your Euclidean geometry and check if you're very good at it, right? And also learn how to work with variables. Learn how to work with variables, right? Because mostly in this topic, we're going to deal a lot with questions that requires us to prove. And whenever that we are proving, mostly we just use the variables. We don't have numbers, right? So we just learn how to use the variables, right? So if you're choosing the formula, guys, choosing the formula to use. So choosing the formula to use depends on what you are required to find, right? What you are required to find, it helps you to understand which formula to use, right? Because some of the times you can be given, find the area of. So obviously if you're given that kind of question, find the area of, it means that you must apply the what? You must always apply the area rule, right? And if they said you must apply, you must find the side. For example, if they said find the side A, right? And you are seeing that you're having two other sides and only one angle. So it means that you can use the cosine rule. But if you're having two sides, two angles and another side, it means that you can use the what? The sine rule, right? So that's how you can apply this to find your answers, guys. So these are some of the other rules that I had left out. So mostly we're given situations where we're having more than one triangle in one situation. Sometimes you can be given two triangles or three or four, depending on the level of complexity of the question, right? But don't forget that every complex question can be simplified into simpler situations, right? So if you're having that situation where you're having more than one triangle, what you do, guys, this is the trick that you must use. Always find the links between those two triangles. Find the links. What is linking these triangles together, right? So sometimes you can find links like equal lines, right? So if you're having two triangles that are having equal lines, so it means that you can replace that other line in another triangle with that other line in the next triangle, right? So we can have situation like this, where we are having these triangles, right? Can you see that these triangles are two different triangles, right? But they're having a link. These two triangles are having a link, which is common line. They're having the common line. This is a common line. So this line is falling in this triangle, and at the same time it is falling in this triangle, right? So if I ask to prove this line, maybe in terms of whatever that is this side, right? It means that firstly you must define whatever that is this side and link it to this line, right? And then after linking it to this line, then it means that now you can use this line to find this line. Can you see that? So if you're having information this side, it means that you are going to transport every information to that side using this line. And then from then, this line will help you to find whatever that you're trying to find in that line. I'm going to show you examples, guys. Don't worry. This is very, very simple, right? So mostly we use substitutions, right, to replace the common lines. So as you can see, this line, if we have proven that this line maybe is equals to 2xk, maybe it is coming from this side, right? So this side, it means that when I'm using this line now in this triangle, I'm just going to substitute this side with 2xk like that. So that's how you are going to apply, right? So I'm going to leave an example on how to do that, and then from then I'll give 10 best typical exam questions so that you can see how they go around, right? Okay, so this is the situation that we're having. We are told to show that d, which is this small side, is equals to k, which is this side, sine beta, so the sine of this angle, all over sine of theta plus beta multiplied by tan of theta. So if we are checking this situation, we're having two triangles. Can you see we're having two triangles? So we are having this right angle triangle, which is triangle ABC. Can you see we're having triangle ABC, which is having B as our theta, and it is also having C as our 90 degrees. Can you see that? And we are also having AC, which is equals to K. So that's what we are having in that other triangle. And in this other triangle, we're having triangle BCD, right? So triangle BCD is having the following. So it is having angle B, that is there, being equals to alpha. So this angle is alpha. And this angle C is equals to beta, right? So this is beta like that. And then it is having line BD being equals to D, right? But what are we told to do? We are told to show that this D is equals to this whole information right there, right? So what's obvious is that we are going to use these two triangles, one after the other, to come up with the solution, right? So mostly the length that they're asking you to prove, it is on this triangle. So we cannot start the solution in this triangle. It means that we have to start our solution in triangle ABC, so that we can bring whatever that is on this triangle to try to bring it this side, right? So now after checking the information that you're given, now you check the link. What is the link between these two triangles, right? So the link, we check the links or the common, right? So what is common in these triangles is that they are both having line BC, right? So they're having line BC in this triangle and line BC in that triangle, right? So if that's the situation, if you're having the line that is common, it means that we'll try to find, to use all the methods that we can to find BC in relation to what is in triangle ABC. So we try to find BC in relation to triangle ABC, right? And then from then it means that now we can bring whatsoever that we're given in BC to try to find the side that we're looking for, which is D, right? So BC, it is a yes, BC, it is a common line, so it will work on both triangles, right? So now let's start our solution. As I said, we must start our solution in this triangle, right? So in this triangle, what do we want to bring here? We want BC to start with. We want BC, and we want K, and we want what? Theta, right? But this is a right angled triangle. Can you see that? So it means that in this right angled triangle, we can use the normal ratios that we know, right? So the ratios that should be having opposite and adjacent and theta, right? So this should be tan of theta is equals to the opposite, which is AC. Can you see that? So it's tan theta is equals to K over our adjacent, which is BC. So mathematically, if we are just multiplying out, we find that our BC is equals to K over tan theta, right? So that is BC in terms of what we're given there on top, right? So now let's try to link BC with whatever that we're having this side, right? So we can see that we're having a side and we're looking for another side and we don't have this side. So the cosine rule won't work. But the sine rule can work because now we're having the angle opposite to the side and we're having this side that we've proven here on top. It should be related to this angle. But you can find the value of this angle because this is a what? We're given all the angles that are there except for this. So we know that our D plus our alpha plus our beta is equals to 180, right? Because these are sum of angles in a triangle. So these are sum of angles in a triangle, right? So this leaves out our D being equals to 180 minus alpha plus beta. Can you see that? If we take this whole thing to that other side, it becomes negative. So it's 180 minus alpha plus beta, like that, right? So let's see. Sine of 180 minus alpha plus beta over, right? So sine of this angle over this side, so over BC should be equals to sine of this angle over D. So this is sine of beta over D, right? But we're trying to make D subject of the formula. And before we can go there as well, from reduction formulas, we've learned that if we're having a situation like this, this is the situation in the second quadrant, so sine becomes positive, right? So this is sine plus beta over BC should be equals to sine beta over D. Now we can multiply it throughout by D. So, or we can rearrange this formula as D sine of alpha plus beta is the same as sine beta multiplied by BC. So cross multiplied there. Can you see that? Right? So our D now becomes our sine alpha plus beta. So this is more like we are solving the identity now, right? So this will be equals to sine beta multiplied by and then the value of BC, it is K over tan of theta. Can you see that? So now, sorry, this is multiply. So now our D multiplied by sine of alpha plus beta will be the same as K multiplied by sine beta over tan theta, right? Can you see that? And now lastly, we can divide throughout by this. So it means that lastly, our D becomes K sine of beta all over sine. So this is all over sine alpha plus beta tan theta. So we divided throughout by this. So got this answer, which is the same as this one. Can you see now how we can go around the solution, right? So I'll cut this video here and I'll do another one explaining a different question, right?